Here are the answers to Thursday's worksheet. I'm going to work through all of them. Let me zoom in a little bit. Number 1, write the equation of the line shown. So you need to find 2 points that are really on the line in order to find the slope. So if we look carefully, whoops, something just zoomed out on me there. Let's try this again. Okay, so, whoops. Let's look at these points on the line. It crosses right here at -6, 0. Where does it cross exactly on a grid again? Well, it crosses right there exactly on a grid, and right there. So if we look at our slope, which is rise over run, the first thing I'm going to do is I'm going to look and I'm going to say, is it positive or negative? And I can see that it goes down as we go left to right, so it's a negative slope. And it goes up or down 1 as it goes across 4. 1, 2, 3, 4. Alternatively, I could have picked those 2 points and said, let's see, my first point is -6, 0, and my second point was -2, -1, and plugged them into this formula, the slope formula. That's another way to do it. Pick 2 points that I can tell for sure are on the line and calculate it. Right, so that's my slope. Then, easiest way is to pick the I can't do the y-intercept. I could guess it's at 1.5, right? But instead, if I use my point slope form, I would have, let's pick an easy point. Let's pick a positive point. This point right here is +2, -2. So if I pick that to plug in my formula, I'm going to write my formula on the top left here just to keep things a little bit clean. I'm going to have y minus the y value, which is -2, equals -1/4 times x minus the x value there, which is a +2. Right? So I'll have y plus 2. I didn't leave you very much room here, did I? Minus -1/4 x, right, plus 1/4 times 2. 2 divided by 4 is 1/2. So I get y equals -1/4 x, right, minus 3/2. So my 3/2 I got from I subtracted 2 from both sides. Right, and that looks like where we thought it was looking at the graph. All right, now next thing, write an equation of a line perpendicular. Well, the first thing we always need in writing the equation of a line is the slope. So perpendicular means I need the negative reciprocal of what was before. So my slope before was -1/4. So my slope now, I've got to turn it upside down, and if it's negative, I need to make it positive. So 4/1 equals 4. And now it says a y-intercept of 5. That makes our line pretty easy to put together. I'm going to write y equals mx plus b. If I have the y-intercept, I can use that form. My slope is 4. It says my y-intercept is 5. So that's my correct equation. Let's look at the next one. If I look at my next graph, I can tell it's an absolute value. If I've paid attention to what... So I'll take this and move it up. There we go. What my different graphs look like. So I know it's based on an absolute value. Wow. I'm having a little trouble with the scrolling with the PDF in here. Let's see what, all right. And then I have to figure out how much is it shifted. It's not turned upside down, so I know it's not reflected. It's shifted 1 to the left, and then it's shifted 4 down, right? 1 left, 4 down. So in order to put those in, to the left means I have to add a value inside my parentheses, And the up and down is always outside the function. Always gets tagged on the end. All right, our next transformation, sketch the square root of x. So my square root of x, square root of 0 is 0. Why is it doing this to me? Ah! I'm clicking on something that somehow is, I'm leaning on something on my tablet. That's messing it up. All right, let's try this again. I'm going to have 0. The square root of 4 is 2. Right, and the square root of 1 is 1, and the square root of 9 is 3. 1, 2, 3. So we're going to have these points, and it's going to look something like that. Right, if I needed to, I can make a chart. Now, why did I skip to 4? Because I know that's the next one that has a perfect square. I could do 3, but the square root of 3 is, 1 point something strange, so I don't want to mess with that. All right, let's look at the real question here, is the shifting. So negative means it reflects. It means it's upside down. Reflects about the y-axis. And this plus 5 inside the square root means to the left 5. So I'm going to go to the left 5, start over here. And then it goes upside down. So it's going to go down 1, down 2. Let's see, 1, 2, 1, 2, 3, 4. All right, so it's going to go like that. All right, that's my shifted version. So those 3 were fairly straightforward. The next page was hard. And in fact, the last one probably was too hard. So sorry about that. I want to move this. Let's clear my, no. Yeah, let's do that. Okay, now we're on sheet 2. I sent you a hint. I hope you saw it. We're going to look first for some points that are definite, that we can put a point on the graph. So if I start here, I have a y-intercept of 1. For some reason, when I change pens, it wants to retract on me when I change colors. Okay, it has a y-intercept of -1. So let's put that point on there, y-intercept of -1. The next note is an increasing interval. Let's wait for that for a minute, and the decreasing intervals. Let's look at something I can definitively point at again. A local maximum at 3, 6. So 1, 2, 3, and then up 6. I know that's the maximum point I'm going to reach, right? And a local minimum at -2, -3. So I'm going to go -2 and down 3, -2, -3 is a local minimum. So one of the ways you can think of these, if that's a minimum, that means near it, it's got to go up from there. If it's a local maximum, it means around it, it's got to go down from there. So that's going to kind of be the shape. We get a feel of whether we have to go up or down from there. So we've taken care of the minimum, the maximum, and the y-intercept. So we have a few very specific numbers. What else do we know? We know it, let's look at the last one. It goes from -infinity to 8. So on this left-hand side, it's going to go forever, and on the right-hand side, it's going to stop at 8. All right, now we have increasing and decreasing areas. So I'm going to write these along the bottom to start. So f of x is increasing on the interval -2 to 3. So that means going up. Decrease means going down. All right, so from -2 to 3. Here's -2, and here's +3, our maximum. During this part, it's going to be going up. Let's look at our decreasing intervals. From -infinity to -2, it's going to be going down. And again, let's see, from 3 to 5, it's going to be going down. So here's 5, it's going to be going down. We're not told what happens in here, so we could do whatever we want, and it ends at 8. So if I try to put these ups and downs in here, I'm going to write them in a different color for a minute. If I write this like this has to go down, this has to go up, this has to go down, and at 8 it ends. So I have a few choices. I don't have much of a choice in the middle. It goes up here and it has to go through -1. So I don't know how it curves, but it goes up through there. Right? And I know now on the left, it comes down to the minimum. Well, now what happens on the right? I don't know. All I know is that between here and the 5, it goes down. I have choices. It could continue to go down till it gets to 8. That would be correct. That would match everything we knew. At that point, it could suddenly turn and go to 8. That would work. It could even go up. It didn't say that was the only minimum I had. It could go up. I don't know what's happening here, but I know it's got to stop at 8 with a dot. So I have choices on that side. On the left-hand side, I did have to be decreasing, but I'm going to show some things that also could happen. Maybe it would be a shallow decrease. It didn't have to be steep. Right? So you have some options in between. Right? That was a hard one. I granted that was a hard one. Let's look at the next one, which is also really hard and was probably too hard. And I feel like I hope you didn't spend hours on it. I feel a little unfair. But let's look at what's going on here. We're asked to describe a piecewise function on these 3 intervals. So the intervals are always the domain. Right? So I'm going to do some drawing here again to get a picture. It doesn't jump between 3 and 6. So that means there's no holes in the graph. And one piece is a constant function, one's a decreasing function, and one piece is increasing. So constant means it's going to be a flat line. Decreasing function means it's going to be going down. And increasing function means it's going to be going up. So you could get crazy creative with this, but let's not. So let's just look on the number line. Well, here's our y-axis. From 1, 2, 3, here's 3, 4, 5, 6. Here's what's happening. We've got a function that we're going to describe in 3 different pieces. This to the left area is -infinity to 3. The middle area is 3 to 6. And the right-hand area is 6 to infinity. Now, we're told we have to put 3 different things in here. A constant function, a decreasing function, and an increasing function. We have choices. It could look like this. It could be like increasing, constant, decreasing. It could look like constant, increasing, decreasing, constant, decreasing, increasing. We just have to have one of each, decreasing, constant, increasing. As long as we have one of each and it makes sense. Now, what it means by not jumping is that at these points at 3, this would be 3 and 6, it's continuous. So we're not making a function that looks like this, jumps down here, and then increasing, and then up here, constant. There's no holes. No holes in it. So let's see, how can we put that together? Right? I'm going to do like a soup, the easiest one I can think of to start with. Let's draw something. I'm going to make this 3 just because I know that will make it easy. I'm going to do from 3, 3. And let's make it constant. And then from here, we're going to make it go down again. 1, 2, 3 to 9. And up. Now, I did this deliberately to make life easy on myself. All right, and this goes forever down here, and this goes forever down here. So I've got my 3 pieces, but how do I write it down? Right, I have to write each piece separately. So let's look from -infinity to 3, what's happening? I have an increasing line. Now, if I look at my line, the y-intercept is 0, so a different color right there, y equals 0. And my slope is 1. I did that on purpose. Right? So if I use y equals mx plus b form, and m is 1, the slope, and b is 0, I get y equals x. Okay. If I look at the next piece, from 3 to 6, it's a constant, so it's just y equals 3, doesn't change. And the last piece, from 6 to infinity, I get it's a negative slope. And so I'm going to go over to the right-hand side here on this area. M equals -1. All right. I don't know right away what my y-intercept is. So I can do my point slope form, y minus y sub 1 equals m times x minus x sub 1, and use either one of these 2 points that I have. I have an intercept at 9, or I have 6, 3. Let's use 6, 3. Let's use the point 6, 3. So I'm going down to the bottom right again. I'll have y minus 3. That's the x value, or the y value, I'm sorry. Slope of -1, and x minus, what's my x sub 1 value? Excuse me, it's 6. Okay. I'm going to continue working that out. So I get -x plus 6. Then when I add 3 to both sides, I get y equals -x plus 9. So I have to use what I know about equations of a line, figure out my slope, figure out my points for whatever decreasing line I might want to have written. Then how do I write this whole definition? I'm going to write it in pieces. So this tells me on my first interval, it's defined as x. On my second interval, it's defined as 3. And on my third interval, it's defined as -x plus 9. What are my intervals? My first interval is from -infinity to 3. But the way we usually write this in a definition, that means x is greater than or equal to 3. Or less than or equal to 3. So for all x's that I want to input that are equal to 3 or less than 3, I can use the value x. My middle interval from 3 to 6, right? Open interval on both, is it? No, I think 6 we had a closed interval there, if I'm correct. Yeah, a closed interval there. So that would be for x between 3 and 6. And it can be equal to 6. And finally, our last interval says from 6 to infinity, which means from x is bigger than 6. So that's how we would put that together. That was a very challenging problem. If you got partway through, good for you. If you got the whole thing, wow. And again, there's an infinite number of choices that you could come up with on this. This is just one, but it shows you the method of it and hopefully gives you a better understanding of piecewise functions. I will not make you do something this hard on the test, just so you don't stress over that too much. Okay, if you've got any questions, please always come see me.